Alright, in today's lesson we have a look at problem number 5. Number 5 asks us to sketch the graph of a rational function and identify several properties of that function. The first thing I want to do is I want to take a look at the equation and I want to factor it. I factor the numerator as x minus 1 times x minus 7. And the bottom is prime. In other words, you can't break it down. You can't factor it. And when I see that this is the case, because there are no common factors, I know that there's no point discontinuity, or as they call it, removable discontinuity, which means the same thing. So I'm going to start my list with identifying any asymptotes. I'm going to take a look at a horizontal asymptote, vertical asymptote, and a slant asymptote. When do you have a horizontal asymptote? Well, you have a horizontal asymptote when the degree at the top is equal to or smaller than the degree at the bottom. Oops, that's not the case. You have the degree at the top bigger than the degree at the bottom. And in that case, we have no horizontal asymptote. Now, to determine the vertical asymptote, we will look at the denominator. And you will set the denominator equal to 0 and solve. And when I do that, I get x equals 6. When do you have a slant asymptote? When you have the degree at the top higher than the degree at the bottom, which we already said it was, by 1 degree. So when you have 2 at the top and 1 at the bottom, you're higher by 1 degree, then you do have a slant asymptote. If the numerator at the top had been a 3, then you would be top heavy, so to speak, but you would not be top heavy by 1. You would be top heavy by 2, and therefore no slant asymptote. But we do have a degree at the top 1 higher than the degree at the bottom. So we use synthetic division to determine what that equation would be. And in the little box, you will put the opposite of what you see in the divisor. In other words, you see a minus 6, you put a positive 6. And then you put the coefficients of the numerator, which is 1, negative 8, and 7, next to in line with a 6. Skip a little space, draw a line, and you start the process. You drop the 1, multiply, place it in the next column, add. Multiply, place that in the next column, and add. Now these are the numbers that you are going to use to make your equation of the slant asymptote. If you remember, the number on the far right happens to be the remainder. And that's not going to be part of our slant asymptote. And the next number to the left of the remainder is your constant, and this is the coefficient of x. So you would write y equals 1x, or x, minus 2. And that is your slant asymptote, which we're going to use to make our graph. The next thing we want to address is any intercepts. The x-intercept and the y-intercept. To determine the x-intercept, that's when your y is 0. And y is 0 when the numerator is 0. And the numerator has been factored. So what are the values of x that make the numerator 0? Well, x would be 1. And when x is 7, you have the graph intersecting the x-axis. Where does the graph intersect the y-axis? That will occur when you let x be 0. So we have x is 0 would give me my y-intercept. Let x be 0, and if you use your factored form, that helps work the problem out quicker, I think. So 0, 0, 0, that'd be negative 1 times negative 7 is positive 7 over 6. So that would be a negative 7/6, or negative 1 1/6. Okay. What are some of the other things they asked me to identify? They asked me to identify any discontinuities. So do we have a point discontinuity? The answer is no, or none. Finally, the domain and the range. Okay, let's take a look at our graph first, and then that'll help us analyze the domain and range. We have a vertical asymptote at 6. So 1, 2, 3, 4, 5, 6. X equals 6. I identify that on the graph. And then we have a slant asymptote. Now I'm going to use the skills that you have, from Algebra 1. How do you graph the simple linear equation? I take a look at the intercept first. So it intercepts at -2, and it also has a slope of +1. So if I rise 1, run 1, there's another point, rise 1, run 1, and I keep doing that. And that will help make my slant asymptote. Now remember, these asymptotes are broken lines. They are not solid lines. They are not part of your graph. They're only guidelines for your graph. Okay, now we have other information. We have the fact that the x-intercepts are 1. And 7. So 1, 2, 3, 4, 5, 6, 7. And there are no point discontinuities, and we have a y-intercept of -1 and 1/7. So that's approximately here somewhere. Okay. Now I know that the rational function is usually 2 branches, and I know that one of these branches will have to be in this section here, and the other will have to be here because of the points we've located. So I'm simply going to sketch my graph, and then this would come up along the asymptote and branch out this way. Okay, there's my graph. Now I'm going to answer the question about the domain and range. The domain has to do with the x values used to make this graph. And as you come in from the left end of your graph and scroll to the right or move to the right, there is one place where there's a break for the x values, and that's when x is 6. So what you have is you have from -infinity to 6, and it does not include 6, so you have to use parentheses, and of course parentheses for domain, union 6 to infinity. And then you have the range. Now this can be very tricky, because if you look at either of these 2 branches, it uses all of the y values from -infinity to infinity. And that's one possible way of demonstrating your domain and range.